All right, we'll get started. Welcome to our 1 p.m. briefing, The Future of Food, Technology Tackles Food Security Risks. My name is Andrea Cordy. I'm a writer here at AAAS, and I'm happy to introduce our panelists here today. First is Étienne Hainzelin, counselor to the president at CIRAD and visiting professor at the University of Ottawa. Second is Catherine Lilian Nakalambe, assistant professor of research at the Department of Geographical Sciences, University of Maryland, College Park. Third, Mario Zappacosta, senior economist, team leader, Food and Agriculture Organization of the UN. And I will turn it over to Étienne to begin his remarks. Each speaker will present for a few moments, and then we'll open the floor to questions. Étienne.
Thank you, Aria. So good morning, good afternoon, everybody. One of the roles of scientific research is to challenge conventional truth. And I think most of the time this conventional truth come from the fact that we tend to oversimplify a situation, we globalize solutions, and we don't take into account the huge diversity of situations. So 2 examples of this conventional truth. Food security, everybody knows that there are many risks for the food security of the world. For a long time, we thought that producing more would be a solution. We know perfectly that it's not a solution. Sometimes it's exactly the reverse. And we still have in mind this conventional wisdom that producing more will solve the food insecurity in the world. A second example is the meat production and the climate. If I ask you today, is it good for the climate to eat and to produce meat? Everybody will say, no, it's not good, it's really bad. And in fact, it's true. 15% of the greenhouse gas emission comes from meat production and consumption, mainly from production level and mainly from enteric emissions. But this is also a conventional truth that I want to challenge here in this presentation. Because if you go down to a specific situation, and then let's go to the drier part of Africa, Sahelian regions, where 200 million people live from pastoralism and pastoral systems. Some of these countries are 1/3 of their job number comes from these activities of pastoralism. And in Niger or Mali, for example, up to 40% of the GDP comes from this production. So it's a huge challenge for them to be able to understand well. And if you go how this system works, they are extremely resilient. They are based on mobility. They have 3-4 months of rainy season where they stay there, but the rest of the year they go and go to the resources. So the mobility is the key of their resilience. They go to the water, they go to the grass, and they travel sometimes more than 100 kilometers a day just to find these resources. So instead of putting input in a production system, they go for the resources. And this creates a very specific food system in this region, in these societies, that have specific resilient parameters and specific performance parameters. They've been established along the centuries, and so if you apply to this kind of production the reference standards of meat production, they are extremely bad. I mean, they are emitting greenhouse gas, and they are bad emitters because they are producing meat. And so CIRAD research went in the field and tried to understand, because when you apply these norms and standard reference, you're based by the kilo of meat, of produced meat, and you apply to the system. So another way to understand the real balance of carbon prints of this system is to go to the field and to analyze and to compute all the inputs and outputs of the system at the landscape level. And when you do that, you don't only consider the cattle, but you also consider the termites, the fires, the plants, the bushes, the soil functioning. And we did that, and we measure during a year the very precisely all the movement of the cattle, what they eat, their dejections, how they travel from one region to another. And at the end of this analysis, we compute all the things, and we discovered that actually this system are almost carbon neutral. And they are almost carbon neutral because the way these animals are traveling, the ways these animals are feeding, are reproducing, it's extremely adapted to the scarcity of resources in these very dry areas. So this is a conventional truth that is being challenged by this research. And the other results that we have in these results was the fact that we realized that with small improvement in the system, you can even make the system mitigator of the climate. They can be negative in terms of carbon print. So these are based on animal production. They represent a huge livelihood for a huge share of the population of these countries, and they can be in their roadmap for climate mitigation, which is very important. So this is an example how we can challenge truth, conventional truth, and how we have to tackle food system in a systemic way to understand how we build up their resilience to risk. Thank you very much. So if you're interested, I brought the papers describing this research in Sahelian region.
My name is Catherine Nakalambe. I'm an assistant research professor at the University of Maryland. And just to summarize some of the work that we're doing, for many African countries, as Étienne was just mentioning, food security is one of the most pressing issues of today. And my job as the Africa program lead for NASA Harvest, which is a consortium of over 40 partners, is to help countries build their own agriculture monitoring systems based on free and low-cost satellite data to inform life-saving decisions related to food security sooner and with a deeper evidence base. So our work at NASA Harvest focuses on using satellite data to understand agriculture and food security at local to global scales. Satellite data have been used for many decades by organizations like the United States Department of Agriculture, but not in many countries, particularly in Africa. And NASA applied sciences programs such as Harvest and Severe redoubling NASA's investments in making satellite data more useful for agriculture monitoring. Combined with field data, of course, we can use this data to understand at a much larger scale what food crops are produced where, how they're doing. We can estimate how much food will be produced within a season and provide early warning of crop failure. This early warning information gives organizations more lead time to prepare a response and mitigate impacts altogether. We have many amazing, we've had a lot of impact in our work. For example, in Uganda, NASA satellite data has been used to avoid crisis. In 2015, for example, to respond to a food security emergency. And since 2016, they implemented the same data into a process to design a disaster risk financing program that has supported over 300,000 households, saving the country millions of dollars. For example, in 2017, they saved $2.5 million. This is about 50% of the emergency budget a year in response to food security in the Karamoja region in the Northeast. And this is in part due to having access to NASA's data and as well as the capacity that we have built in Uganda. We work with stakeholders in over 10 countries currently to develop satellite-based agriculture monitoring systems. 3 of these countries have officially launched their own satellite-based agriculture monitoring programs. And we now also have a regional program which has led this country efforts to be much greater, whereby through a regional program, there is a coordinated response. For example, given the current locust invasion in Eastern Africa, we have a regional crop monitor initiative, which has led to countries that are likely to be impacted to be more prepared. We face challenges, of course. It seems pretty straightforward that this data would just be used and adopted. However, the lack of capacity to interpret the data and the lack of trust and therefore reluctance to use satellite data is one of the key problems that we have. And one key to the success that we've had is building trust and co-developing processes and tools that are directly responsive to user needs at all levels. It is always work in progress, but the strength lies in the countries actually using this data to inform their decision makers. Science-based data should be paramount in decision making, but many countries are not in position to make the required investments to use this data. And the investments of NASA, ESA, and programs such as the Global Agriculture Monitoring Initiative, NASA Harvest, NASA Severe, the Copernicus program from the European Space Agency, and others are critical in supporting this resilience-boosting work across the continent and beyond. In Africa, we're now focusing some of our work at NASA Harvest in coordinating with our partners on the development of operational semi-automated methods for in-season crop type, crop area mapping that is essential when you're improving decisions that are based on satellite assessments. Using machine learning, we want to take advantage of the explosion in satellite data, and this is at the forefront of our research. It's really exciting because it is enabling us to study larger areas at the right scale for smallholder agriculture, which is a huge percentage of agriculture in sub-Saharan Africa, and most importantly, being able to develop these data sets for regions that are inaccessible, areas that are in conflict. Food security is rife in these regions where there is political insecurity, and early warning information of food insecurity is more critical in these areas. When we cannot collect ground data, the accuracy of satellite-based assessment reduces tremendously, but with big data, machine learning, we can do a reasonably better job. We can train computer programs where we have ground truth data to make predictions about areas where we have little to no information, thus informing critical emergency and humanitarian responses. Thank you.
Hello, everybody. My name is Mario Zappacosta, and as I was presented, I'm a senior economist. And I think these two words will come back later as an important information for you, because the tool that I'm going to present you, it's something very technical, but has been designed to be understood by economists and not by specialists in remote sensing, and maybe also senior, so maybe people that is not so keen with the latest development. But it's such a powerful tool that even economists can use it. So what I'm going to focus is on one of the issues that triggers food security and losses in crop and livestock production, that is drought. We know that drought is a special event. The severity and frequency of drought is increasing with climate change and other mega trends on the globe. And it has a tremendous impact on livelihoods and households' survival across the globe. As FAO, Food and Agriculture Organization, we focus mainly on poor countries, so those countries that have less capacity to cope with this type of events. So a few years ago, let's say recently, FAO, with the support of the European Commission, decided to produce an index. The index that you can see on the screen is called Agricultural Stress Index, and it's a quick look indicator for the early identification of cropland areas that may have a high likelihood to be affected by a drought event. What we do is that we use 1 kilometer resolution images. That it's not, let's say, high resolution images, but for our purposes is quite okay to detect drought developing in the countries. And we take into consideration two main dimensions: temporal and spatial dimensions, because we are first of all interested in the time when the crops are in the field. We can read in the newspaper sometimes that a drought is developing somewhere, but for us it's important when the crops are grown in a country, so from planting to harvesting. And then So we are interested in the time, and then in the space. So where the crops are, we know that in many countries, especially in sub-Saharan countries, agriculture is just developed in some areas. So we need to monitor. And if you see this this map, you can see that a lot of parts are in gray area. So it means that they have been masked out from the part that we monitor. So the colored areas are those that we monitor, and we receive satellite images every 10 days. Here you can see that the greenish parts are the good ones, so even an economist can immediately understand what is the message. You can see this is the third decade of June 2019. I selected just randomly. You can see that there was some problems in parts of eastern Australia. And then what we do, this is a tool that has been developed at global level. So there are parameters behind that maybe, as again an economist, I don't fully understand, but I know that is based on the philosophy that one size fits all. So it works better for some area, worse for others. So what we are doing now recently, we are going at country level. So we have the possibility to calibrate the tool at country level. Maybe next slide. And a lot of parameters can be better fine-tuned, like the crop mask that we use, so the crops where they are, the crop calendar, when the start of the season and the end of the season. So this is a much more powerful tool at country level, so the countries are empowered to use the tool. To conclude, what is the use that we know is from the countries, apart from obviously the early warning on drought? The ASIS has been used also for trigger the mitigation measures. So the governments, as soon as they see reddish area developing, can implement some actions, and we know that earlier we act, cheaper than is the tool, let's say the activities that we have to do to save livelihoods. And then it has been also used for index for premium in insurance, or even to design long-term investments to protect agriculture and livestock by drought. I think I can close here and receive more questions.
Great. We'll open the floor to questions now. If you have a question, please raise your hand. A microphone will be brought to you. Please state your name and affiliation before asking your question. So if anyone has anything that they'd like to share, yeah, in the back.
Hi, so it's Kath O'Driscoll from Chemistry and Industry magazine. And maybe I can ask Catherine, I've been reading about the devastations being caused by the locust invasion. And perhaps you can say a bit more about how the tool is being used to look at the spread of the locust.
Yeah, please.
So in Eastern Africa, we worked with the IGAD Climate Predictions and Applications Center. IGAD is the Greater Horn of Africa, and this initiative is primarily focusing on crop monitoring. So we have a group of individuals that come from different countries that are reporting into this tool that we sort of pull all this information together and share it to a broader community. What has happened with the locust invasion is that initially when the locusts started in the Horn of Africa, there were alerts that came out from FAO talking about the locusts would be coming, and initially it seemed like a normal event, but then in Eastern Africa they've experienced extreme anomalous rainfall in December, October, November, December, which is typically a dry season. And this sort of creates an environment where it's much more favorable for locusts to sort of breed and grow. In addition, what happened also later in December, there was a cyclone that brought a lot of wind, which is critical, or which is important for locust basically movement. So they were all blown south towards Kenya. And basically in Kenya, given the anomalous rainfall, which is completely not normal, there's a lot of vegetation for the locusts to feed on. And so the swarms have been growing bigger and bigger. But through that, sort of the crop monitoring initiative is that IGAD has a responsibility for over 10 countries. So Somalia, Ethiopia, Uganda, Kenya, Tanzania, all of these countries are part of that network. And Key has been sharing information across how they're traveling. Part of what they're trying to do is use satellite data to try and figure out where they're going to go next. So looking at wind direction, soil moisture, these things that are important for locusts to sort of breed and continue to expand. And what that did is for Rwanda and Uganda and Tanzania, they're on high alert because of this information sharing. So IGAD sort of shares this report that everybody pays attention to, and these countries have sort of been setting up their own response programs. And as of last week, the locusts made it into northeastern Uganda, but they had already had discussions about how to deal with, what's coming. But right now, it's sort of a really, really big problem, also because it's continuing to rain, so the conditions are even getting better for the locusts to continue spreading. There's a high probability they'll make it into South Sudan, which is, it's going to create a much greater program. And given the growing season is starting, the crops that are growing or will be planted at much higher risk. So that's one of the reasons why the FAO is warning, they need to deal with it right now before it turns into a famine, because by the end of August, all the harvests that were supposed to be, realized in all these countries will be lost because none of the crops made it. I don't know if that's a good response.
Are there further questions? Yes, right here. Just one, you can wait for the microphone. Thank you.
Maybe this is not your field, but since you raised the issue, what can they do about the locusts? What can be done to minimize the impact or kill them or what?
It's definitely not my field, but I've been doing a lot of learning, mostly because of my role as coordinating the stuff that's happening in the different countries. And maybe Mario can add as well.
Well, again, as an economist, I have little knowledge about, the action, but I'm sure that part of the spraying of the swarms, it's one of the actions that we can, imagine. And there are also actions that are made in supporting the people affected. The two activities are in parallel. One is to control the insects and to avoid that they make further damages. But then there is also another activities that the international community is aware, is that they have to protect the people that have been affected. And as Catherine said, the locust started their movements in December, when most of the crops in the Horn of Africa were almost all harvested already. And this was a good news. So so far, the real damages were localized and not so strong. But the big concern is for the next season that is about to start now in March. Rains are expected to be abundant. So there may be like two situations that may lead to a reduction in the harvest in August, is that either farmers plant and they lose because the swarms can eat the young plants, or with the risk of the locusts, they don't plant at all. So obviously the result is the same, and we may experience a reduced production across several countries. In the last few years, we always had problems, let's say, in one or two of the countries in the Horn of Africa. The risk this year is that we may have problem across the region, and this is, really.
Maybe I can add on the response. Actually, this morning we were speaking with colleagues from West Africa, who have a lot more experience dealing with locusts. So they don't, in East Africa, they don't show up every few years. In West Africa, they show up a little bit more. So they're saying right now, for example, in Kenya, that it's a 1 in a 70-year event. It's really bad. For East Africa, it's a 1 in a 25-year event. It's different for each country. But in the experience in West Africa is one of the points that was mentioned this morning is that spraying makes a lot of sense, but then it sometimes and a lot of times equals a lot of pesticides being sprayed. And some of the communities in West Africa, pastoral communities, have methods for dealing with locusts. They, for example, dig holes that equal traps. So the locusts sort of, when they're still hopping, they hop into those big holes and then they just burn them on these like smaller localized sites. But at the level it is right now, I think it's beyond that because they're incredible. If you see how they're like huge. They go, so many kilometers across, and they're not in the hopping stage where they would just be stuck in the hole. So, I don't know if that's a good response. Yeah.
Any questions? All right. Well, while we wait, I have a question for Étienne. I'm wondering if you can speak about what kind of factors go into, you said about the carbon neutrality of the food system in Sahelian regions. What kind of factors are you looking at there?
The fact that it's doubly unfair for this population because they have to adapt to the drought and they have to travel much farther to get the grass, and they are accused to be emitting green gas. So the several factors that can be improved, for example, is that first of all recognize that the breads, the bovine breads are much more adapted to these pastoral systems in terms of genetics, and they can feed on very low. Generally, what we found is that they just touch 1/4 of the biomass when they pass on. So they respect the kind of thing. The second thing is that we have to improve the way of getting to the water holes, to the ponds, to these herds, because that's where the dejections are, and that's where we can collect these dejections to make to improve and to reduce the carbon emission from these dejections. The third point is that there are ways, because there is not only herds on one side and farmers on the other, they're always connected, and most of the pastoral people are also growing things. One of the things is that you can have mixed systems where taking advantage of the rainy season, you can kind of start harvesting grass and making hay. They don't used to do that, but they can do that. And if they do that, they increase their production, their performance, and also they decrease their emission of gas. So there are several ways you can improve that. And since it's the livelihood of over 200 million people in this region, you can build policy on that.
Okay. Great, thank you. Are there questions in the audience here? Yes.
So it's Kath O'Driscoll from Chemistry and Industry magazine. Just following on from that, I wonder, Étienne, if you could say anything about how developed world sort of cattle rearing methods, have you learned anything about that, how that might be improved from the studies that you've been doing there? Is there anything about the genetics or anything that any sort of thing that we could do to mitigate impacts based on what you found?
I think in the range, in the classification of factors you can improve, genetics would be the last one. Health would be one of those. If you manage to get better health for the cattle, you can get that. If you manage to get kind of insurance for these herders and better access to water and grass, it's very good. Because these systems are extremely resilient by themselves. They move to the resource, they move to the market. Compared to the traditional meat market where you get frozen carcass from the outside, the balance of the energy and the resilience is much more for this system. So I don't think genetics would be the first factor to improve. You have to improve, first of all, the management of the commons, the water and the grass, the possible conflict around these commons, the health, and the access to other resources and to markets.
I'll take more questions. Anyone has any? Yeah. Please do. We've got the mic here in the second row. Thank you.
Yes, hello. And I'm not a journalist. I'm the session organizer. But maybe there's one point I would like to add, which could be of interest also to the audience, perhaps. Maybe if you can say a little bit more about working as networks. I mean, the reason why the three of you are here and also will speak in the session is that I think CIRAD, for example, and FAO are part of the global network against food crisis, which is quite important in terms of providing information about global food and nutrition security, and for example, the European Commission that we are working for is very interested in your results and in the consensus that you can reach in providing information which is otherwise comes from so many sources that it's often difficult to keep to understand and to keep an eye on. And I know also that, for example, both CIRAD and Mario and also Catherine, you're part of scientific networks such as, for example, the GEOGLAM, the global agricultural monitoring network of the Group on Earth Observation. So I find this very interesting that you are all participating through different networks to improve information for policy. Maybe if you can add one or 2 points on that.
I can just quickly maybe comment on the Global Agriculture Monitoring Initiative. The idea, I guess, coming from the fact that there are many information providers, there's a lot of value with remote sensing, and so many organizations use remote sensing information to inform decisions. And there's a lot of advancement based on where you are, what kind of data you have access to, technology, tools, and expertise. And one of the key initiatives in GEOGLAM, that Group on Earth Observations Global Agriculture Monitoring Initiative, is to try and coordinate assessments across different agencies. So the UN Food and Agriculture Organization, the World Food Program, Famine and Early Warning System, the Joint Research Commission. So what we do on a monthly basis, we call them crop monitors. Is one that focuses on bigger producer countries, one that focuses on countries that are at risk of food insecurities, and these are the ones that have been adapted also to national and regional level. So the idea is that we have this tool that enables the different organizations to make an assessment, bring all the different information that they use. For example, what Mario just showed in that system is critical when you're looking at food insecurity. You combine that with someone else who's doing crop assessments at a different scale. You combine that with someone who's using crop assessments using the Landsat data, for example, or the Sentinel-2 data. If you were to give a decision maker all these different products, on a monthly basis, they will be overwhelmed. First of all, some of it is not presented in a way that is straightforward, and so the Crop Monitor Initiative tries to bring all these different perspectives into this one simple document, present the maps in a very simple way with very simple key messages that then can be used by decision makers at different levels.
Just to complement on what Catherine just said, I think it's very important, this global orchestration of tools, of policies, because there's a need of global policies about food security. That's obvious. At the same time, what we found as researchers is that the complexity of the food systems requires a local analysis of their parameters of performance, resilience. And the example of pastoral systems is incredible because during 40 years, international funders, international organizations wanted them to sedentarize. That was the only solution. They built concrete schools. They try to sell that. It's a nonsense for pastoral people because their resilience lies in their mobility. So I think there is a nice complementarity in terms of thinking and in terms of policy between big orchestration of policies, of markets, of research tools, indicators, and also a thorough analysis of the specificity of the diversity of food systems.
Questions? Yes.
So sorry, I did join a little bit late. I'm Megan Phelan with Science. I'm wondering if when you synthesize all this information and get it together in that very readable form. If you're learning things about crops that you wouldn't have understood otherwise by just looking at the individual data sets.
Definitely. I mean, this is one of the values of the fact that we have different experts from different places, different organizations, and then trying to link from national, regional, then going to global, because some of the times actually when we do the satellite assessments, we're not quite sure if the signal is equivalent to what's happening on the ground, and we rely on national level experts actually telling us what's happening. For example, not paying attention to a crop calendar, you would say, for example, that crop conditions are great in Kenya right now, simply because everything is green. But it's not the case because all the crops were harvested. The calendars are shifting with all these climate fluctuations, and so you might think the season started when it actually didn't. Sometimes 3 days of no rainfall. If we're looking purely at rainfall, you might think there's a problem. But if there'd been like 6 weeks of rainfall before, then the season would have started normal. And so, I mean, one of the points that you were making is that having this localized understanding of how people are managing the risk is also really, really important, and it shouldn't be. It should be part of that process, and that's why we try to link to as far down as possible. Having access to field data has helped make these assessments much better. The other thing that's happened with the crop monitor for early warning is it's become sort of it has evolved into, instead of being just purely a monthly bulletin, they respond to when something is critical. If a detailed assessment is required for a specific region, for example, when Cyclone Idai, the impacts of that in Eastern Africa, in Southern Africa, it becomes more important to shed light on what's happening with that particular event, like with the Locust, for example. It provides a way to analyze as much data, as much information that's available into a simple, short synthesis that then can be used by others to maybe find out more about what's happening.
Yeah, if I may add, let's say the beauty, the value added of this type of exercise, it's based on the blending of different type of expertise. So we don't have all Earth observation people meeting and talking about satellite images, but we have people from different fields and from different level. Let's say people maybe like me sitting in Rome and looking at the information I received through my computer, from people in the country talking to the farmers and seeing the rainfall falling or not. So all this information is blended together. But also when we move from an exercise that deals with production to food security, as we know, food security is much more complex issue. So there we really need to expand the network of actors to talk each other, because we have problems, for example, of conflict, accessibility in some areas, prices that are going up. So you may have the production available in the country, but people not in a position to afford to buy. So the move from crop production analysis and monitoring to the food security, it scale up the need of a group, and then the discussion, enriching, and having a consensus.
Are there further questions? In that case, we'll conclude. Thank you to everyone for coming. Thank you very much to our participants. To let everyone know, they will be going into more detail at their symposium, which is going to be held Saturday at 8 a.m. in room 611. In terms of the newsroom schedule, we are not holding a 2 p.m. briefing because of the Bill Gates plenary that's happening on the 4th floor. We will be live streaming it in here, so you're able to watch that in here as well. But please join us again at 3 o'clock for our next briefing, which is on open immigration policies and crime rates. The speakers, if they, depending on their availability, room 208 across the hall will be available for follow-up questions and interviews. Thanks again.
Thank you.